Hi everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. Today in this session we are going to discuss about the frame allocation methods in operating system. So what is meant by frame and how we are going to allocate the frames to each and every process. So generally frames are using in main memory for the paging concept. So here we are going to allocate, we are going to know the details of the allocation of frames, how we are going to allocate the frames for each and every process. So here what is meant by allocation of frames first of all. So when many processes are kept in the physical memory, so all processes are kept in the physical memory which are already inside the physical memory, that is in secondary memory. The way in which the physical frames are allocated to the different process is called as allocation of frames. So the number of pages available in the physical memory are going to be mapping with the frames in the main memory. So how each and every process will be allocated to the frame in the main memory is called as the allocation of frames. For example, if there are 50 free frames are available and 5 processes are available, how many frames does each process can get? So how many number of frames for each and every process can get? So that is the problem. So how we are going to allocate for 5 processes? For 5 processes there are 50 frames are available. So for each and every process, we may allocate 10 frames for each and every process, maybe, or else based on the need of process, we can allocate number of frames, or we can allocate the equal number of frames to the each and every process. So like that we can allocate the number of frames to each and every process. See how to share the frames of the physical memory among different processes is the allocation of frames. So number of frames are available, number of processes are available. So how each and every process can be allocated in the different frames? Is that equal number of frames are available? Is that minimum number of frames are required to each and every process? Or it is a proportional allocation to the each and every process, which is called as allocation of frames. So based on the nature of allocation of the frame, we are calling it as a allocation of frame. And frame allocation methods in the operating system determines how many physical frames are assigned to various active processes. Why we are saying that various active processes means the processes which are ready to allocate the frames and which are ready to execute their job in the frames are active processes. So here how many physical memory frames are assigned to each and every process. That is the way we have to allocate each and every process. The following are some of simulation of the requested method, some of the allocation of frames methods. In that first one is minimum number of frames, and the second one is what? Equal allocation of the frames, and third one is what? Proportional allocation. So let us discuss each and every one by one. So first one is what? Minimum number of frames. The minimum number of frames is the baseline requirement that must be met for a process to execute without causing an immediate hardware exceptions. So without causing an immediate hardware exception, the number of frames which are allocated for each and every process to execute as usual in the job done. So this is defined by the instruction set architecture. The minimum number of frames and the number of frames are available for each and every process to execute without causing any hardware exception, any hardware failures, any hardware interrupts. That will be defined by the instruction set architecture called as ISA. In this, a process must be allocated enough free frames to hold all pages that a single machine instruction might reference simultaneously. So for each and every frame, the enough frames are available, then process is ready to allocate each and every enough frames. If any enough frames are not available, then process cannot be able to allocate the enough frames. So if an instruction for moving a data block requires 6 pages, then 2 for the instruction and 2 for the source and 2 for the destination. This is the instruction set has been divided into, the instruction page has been divided into 6 types. The first 2 are the instruction, 2 for the instructions and 2 for the sources and 2 for the destination. So the minimum allocation for the process is 6 frames. So how it allocates is like this. So empty memory frames are available. If empty memory frames are available, then process is ready to occupy that one. Process is ready to allocate that process. And these are all the frames with the pages, and these 2 are the empty memory frames. Empty memory frames. So the memory frames, minimum number of frames are empty, then the process can be able to allocate each and every frame. If frames are full, then the process can be waiting for the frames is to be empty. So here each process must be given at least minimum number of frames required to execute instructions. The minimum depends on the instruction set architecture. That is what we discussed in the previous slide. Instruction set architecture, 2 for instruction, 2 for the source, 2 for the destination. So based on that instruction set architecture, we are deciding that one. So here in this example, suppose this need minimum number of frames concept, the total frames are available 12 and the number of processes are 3 and the minimum frames required for each and every process is 2. Then how we are going to allocate? So minimum frames are required for each and every process. Even though the total frames are available more, the processes can be utilized minimum frames requirement. The processes can be utilized based on the minimum frames required. So here process 1 can utilize minimum number of frames, process 2 can utilize minimum number of frames, process 3 also can utilizing the minimum number of frames. So total used 6 frames. And the remaining frames can be distributed across using another policies. That means the remaining 6 frames are empty. 6 frames are empty and they are using for another processes, maybe the distributed for another policies. They are distributed for another policies. So how it is allocating the frame of diagram? So minimum frame allocation. The total number of 12 frames are available. Total frames are 12 and processes are 3 and the minimum frames required for each and every process is 2. So here the P1 is allocated, A1 allocation is showing that in the A1 for the P1 and similarly for A2 for the P2 and similarly for the A3 for the P3. So total 6 frames are occupied and the remaining frames, this is the allocated frames structure, and these are all the free frames that are available. Remaining free frames are available for the distributing of another policies, depending upon another policies. These are the 6 free frames available. And the second one is equal allocation. So in this method, the available free frames are divided equally among all existing processes regardless of their sizes. So here there is no concept of the sizes, and all the size is divided into the equal among all the existing processes. Suppose if you see this diagram, this entire 16 kb of the frames, that means each and every frame is 1 kb. So total 16 frames are available. So for the total number of processes are 4, and for all these 4 processes, we are equally dividing the number of frames for each and every process. So equally, that means 4 for A1, 4 for process A1, 4 for process A2, 4 for process A3, 4 for process A4. So the entire available free frames are equally distributed for each and every process. There is no size is mentioning for each and every process. So 1 frame equals to 1 kb, that is frame size equals to page size. That means each and every frame is equal size. Each and every process is having equal size from the frames. So here all processes can get equal number of frames. The formula is what? Frames per process equals to total number of frames divided by number of frames, number of processes. So total number of frames are 12 divided by number of frames are what? 4. So total equals to 3, or 16 total frames are available and total number of processes are 4. Then 4 processes, 4 frames per processes. For each and every process 4 frames are available. So this is the for P1 4, for P2 4, for P3 4, because of the 3 processes are available and total frames are 12. So 4 4 4 equally distributed for each and every process. This is the way we can understand. And here the equal frame allocation showing in the architecture. Total frames are available 12 and the processes are 3 and the frames per process equals to total number of frames divided by total number of processes, that equals to 4. So that means these 4 for each and every process, P1 for process P2 for process P3. So here this is the allocation of each and every frames for each and every process. So these all processes are these are all allocated for process P1. These are all allocated frames for the process P2. These are all allocated frames for the process P3. So how they are allocated? So P1, 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 P2, 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 P3, 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 P3. So like this, 4 frames first for P1, 4 frames for second P2, 4 frames for third P3. So like this, the frames are equally distributed for each and every process. Frames are equally distributed for each and every process. So that is about the equal allocation, equal frames. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.